Okay, so let's go through and look at something that you may or may not be familiar with, and that's nuclear fusion. When I say nuclear reactors or nuclear reactions, most people think of uranium, they think of a nuclear power plant, they're thinking of nuclear fission, where the nucleus is breaking apart and producing smaller nuclei. But we want to fuse nuclei and we want to make things bigger. And so when I was at Clemson for graduate school, this is kind of one of the areas I studied. We were looking at the nucleosynthesis process in the cores of the suns and stars. So we're looking at how stars would produce from hydrogen to helium and then work their way up to iron. So I just want to do the first one. In astronomy world, this is called the proton-proton chain reaction. And then we'll talk about and how it could play a role on the Earth. And then also I've posted a video where you can go through and see some of this reactions and what's really happening with regard to nuclear fusion. So as it says in the name, it's a proton-proton, so we're taking protons. If you look at the hydrogen nucleus, it has one proton and 0 neutrons, and then it has one electron. And we're going to ignore the electrons, we're just really working and focusing on the nucleus. So I'm going to take, so we're dealing with hydrogen 1, hydrogen 1, 1. So you can write it like that or write it as proton. So I'm going to take 4 of these. And I'm going to smash them together. Now, I will be very honest. This is one of the craziest things that happens in nature, and the fact that it just happens is just it's mind blowing. Someone has to wonder if it really does just happen, but that's a whole other story. I'll go into that. We'll potentially go into that later. But you have two protons coming together, and if you've ever taken chemistry, you know protons do not want to go together at all. So the fact that they're being forced together is mind blowing. Maybe not. Maybe it's just to me. So you have two protons coming together, and they produce heavy hydrogen, deuterium. Okay, not tritium, not super heavy hydrogen, but heavy hydrogen. Where now this H21 has two objects in the nucleus, which means it has one proton and one neutron. So now we've produced a neutron. So in this reaction, we have taken one proton plus one proton, and we've produced one proton plus one neutron, plus energy. Then what's going to happen is, you know how we have, if you know how big the sun is, we have lots of these protons floating around because the sun is huge. And I want to take these and smash them together. So I'm going to take a hydrogen 2 and a hydrogen 1 and smash them together. And I'm going to produce helium. And we've already talked about the alpha particle, so we know the alpha particle has two protons and two neutrons, but this only has 3 objects in the nucleus. So a helium 3, 2, I like to call it baby helium, has 2 protons because it's helium, and it has 1 neutron. So it's a lightweight, it's a baby helium, it's not a full-size nucleus, so to speak. And then we're going to take these two and slam them together. And we get regular helium plus 2 hydrogens. You know that part right there. Plus a whole lot of energy. And there's other stuff in these reactions. If you take like a physics 2 class or astrophysics course or something like that, we talk about everything that's happening here. But really, I'm just wanting you to look at what's happening in the nucleus, and we get a lot of energy. So you know that E is equal to mc squared. Well, the mass that's lost, I don't want to say it's lost, but it's lost, is converted to energy. And a lot of energy. So this is what's happening in the sun right now. In the core of the sun, hydrogen is being converted to helium. So if you want to summarize this reaction, you take 4 hydrogens, slam them together, and you get a helium plus a whole lot of energy, plus a few other things that for us, we're just really focused on this basic reaction right here. So all the stars are doing this nice reaction. Now, what's cool about nuclear fusion is the byproducts are not radioactive, as dangerous as uranium. We think of uranium, you think of danger, radiation, death, stuff like that, contamination. So here, the contamination, if this would blow up, it's more of a physical explosion as opposed to a chemical explosion type of thing. So what people are doing on the Earth is they're trying to produce miniature stars on the Earth. So they're trying to produce this reaction and catch the energy that's coming off. Because if you think about it, and why would they even want to do this? Well, if you have the sun, it emits energy in all directions, and the Earth is out here super small. Okay, and this is not even to scale. Everything would be a dot. We catch such a small portion of the energy coming off the sun, and think about the solar panels and everything that's catching all this energy. Imagine if we could catch all of the energy coming off the sun. How much energy we have, and really, would we need to have any other types of energy? So what people are doing are they're trying to create these miniature stars where they can catch all the energy coming off these reactions. And then we're also producing helium, and we have a shortage in helium. If you know anything about helium, we have a shortage in helium, so it produce helium as well. So go through, check out the video that I've shown you. You're going to see this ITER. This is the group that's trying to produce this reaction in a lab or in a nuclear plant setting, where instead of nuclear fission, we're actually doing nuclear fusion. So fusion, we're producing heavier elements. Fission, we're producing lighter elements. The nucleus is breaking apart. Here we're combining nuclei with fusion, and fission, we're breaking them apart. So here's a cool introduction of how we can use nuclear reactions to produce energy in a more of a safe, as far as radiation, safe way.